We're going to be starting section 8.4, which focuses on radical equations. And the last section, we focused on simplifying, and now we're going to be looking for solution sets to problems. So, a radical equation is an equation with a variable under a radical sign. So there must be a variable under the radical sign. It cannot just have x plus the square root of 2 equals 2. That would not be a radical equation. It must have the square root of 2 plus x under the radical. So to solve these equations, we need to isolate a radical on one side. Then we're going to raise both sides of the equation to the same power. We're going to combine like terms. Then we're going to find our solution set, and in some cases we're going to need to factor because there will be more than one solution. Then we're going to check our solutions for extraneous solutions. The rule we're going to be using is the nth root of x equals k, then the nth root of x all raised to the nth power equals k, and x equals k to the nth power. Let's look at our first example. If we're asked to solve 2 plus the square root of 3x minus 2 equals 6, the first thing we want to do is isolate our radical. So we're going to be left with 3x minus 2 equals 4. Now that our radical has been isolated, we're going to square both sides of the equation, and it's important to make sure everything on both sides is taken to the same power. So then we're left with 3x minus 2 equals 16. We're going to combine our like terms. We will have 3x equals 18. Divide both sides by 3. X equals 6. And it's really important that what we do next is our check step, because there may be an extraneous solution. So we're going to go ahead and plug 6 back into our original equation. And when we plug 6 back into the original equation, we will have the square root of 3 times 6 minus 2 equals 4. The square root of 16 equals 4. And the square root of 16 is 4. 4 equals 4. So therefore, our solution can be written as follows, just a 6. And let's take a look now at one where maybe one of the solutions is extraneous. In this example, we're going to be asked to solve and check for the square root of x minus 3 plus 5 equals x. I need to isolate my radical. I will have the square root of x minus 3 equals x minus 5. Now, both sides of the equation need to be raised to the same power. To get rid of our radical, we need to raise it to the second power. And when I do that, I'm going to be left with x minus 3 on the left side of the equation, but on the right side of the equation, I'm going to need to multiply. So I will come out with x squared minus 10x plus 25. If you are confused from the first step to the second step, remember x minus 5 times x minus 5, you need to multiply across. We then are going to combine like terms, and we're going to do that by taking everything on the left side of the equation and moving it to the right. And when I do that, I'm left with x squared minus 11x plus 28. So then, good thing I've refreshed my factoring skills. I'm going to factor, and I will have 0 equals x minus 4 times x minus 7. And we're going to use the zero product theorem that we have used a couple of times this year to find our solutions. So x minus 4 equals 0, and x minus 7 equals 0. X equals 4, x equals 7. Now, I have to do my check step because one of these may not actually be a solution. So when I go ahead and plug 4 back into my original equation, and the original equation was the square root of x minus 3 plus 5 equals x. When I plug that 4 in, the square root of 4 minus 3 plus 5 equals 4. The square root of 1 plus 5 equals 4. The square root of 1 is 6. Of 1 plus 5 is 6. And 6 does not equal 4. And on the other side, when I plug my 7 back into the original equation, the square root of 7 minus 3 plus 5 equals 7. The square root of 4 plus 5 equals 7. 7 does equal 7. So for that one, the final solution is only 7, not 4. Let's take a look at another one. And let's say we have two radicals. If we have two radicals, it's going to look like this. If you are asked to solve the square root of 2x minus 15 equals the square root of x plus 5. We already have our radicals isolated on both sides of the equation, so we can go ahead and take both sides to the same power. And when we take both sides to the same power, we get rid of our radicals. And we are left with 2x minus 15 equals x plus 5. Combine like terms. 2x minus x equals 5 plus 15. Continue to combine. And I'm left with x equals 20. And to do my check step, for this one, I need to plug 20 into both sides of the equation. And so when I plug 20 in under the radical, I have 2 times 20 minus 15 equals the square root of 20 plus 5. The square root of 40 minus 15 equals the square root of 25. The square root of 25 equals 5, and we know 5 does equal 5. So this solution is written as 5. Let's go ahead and look at one more. This one is the most challenging example I'm going to show you. For this one, we're going to solve the square root of x plus 2 plus the square root of x minus 1 equals 3. We want to isolate our radicals. So we want one on both sides of the equation. So I'm going to leave the square root of x plus 2 on the left side. And I'm going to move the square root of x minus 1 to the right. So it will be written as 3 minus the square root of x minus 1. Now that our radicals are isolated, I can go ahead and take each to the second power to get rid of my radical. And when I do that, on the left side of the equation, I'm left with x plus 2. But on the right side of the equation, I need to multiply 3 minus the square root of x minus 1 times 3 minus the square root of x minus 1. And I'm going to write that out because you need to make sure that you are taking every part of that to that second power. So we would have 3 squared minus 2 times 3 times the square root of x minus 1 plus, in parentheses, the square root of x minus 1 raised to the second power. Continue to combine any like terms to simplify. 9 minus 6 times the square root of x minus 1 plus x minus 1. Continue to combine. X plus 2 equals x plus 8 minus 6 times the square root of x minus 1. Continue to combine. I'm going to move my value of my 6 to the left side. Bring over my 8, becomes a 6. 6 is equal to the negative 6 times the square root of x minus 1. Divide both sides by 6. 1 equals the square root of x minus 1. Now I have to repeat those radical steps. So I'm going to isolate that radical on the right side. Then I'm going to take both sides of the equation to the same power, and in this case it's a square again. And I'm going to be left with 1 equals the square root of x minus 1 raised to the second power, and that will become x minus 1, isolate, combine, I am left with 2 equals x. And when I go ahead and do my check step, I will plug in a 2 into the original equation, and the original equation was the square root of x plus 2 plus the square root of x minus 1 is equal to 3. Plug in that 2, square root of 2 plus 2, plus the square root of 2 minus 1 equals 3. The square root of 4 plus the square root of 1 equals 3. 2 plus 1 equals 3. 3 does equal 3. So in this case, my final solution will be rewritten as just a positive 3. So let's review all of these steps one more time. I showed you an easy example, a medium example, and a very challenging example. So the very first thing you need to do in these types of problems is to isolate the radical. Then you are going to exponentiate or take it to the same power on both sides to eliminate that isolated radical. You might need to repeat steps 1 and 2 like we did in our last example if there are still radicals. Then you will solve for x and then check your answers. If you have the third root, that would be taken to the third power. If you have the fifth root, it would be taken to the fifth power, and so on and so forth. So what I'd like you to do now, you have attached to this post a radical equations warm-up paper with only 4 problems. I'd like you to show me complete work and check your solutions. You will be graded based on participation and showing your work. Please do not just write down the answers. You will not receive full credit.